Hello, this is a quick demonstration video showing how to turn power on to our East and West demonstration cabinets here at room STC 237. We've got a couple cabinets here for showcasing student projects. In this case we have an LED oscilloscope based project, and over here we have a sensor project here going to a small bar graph on a printed circuit board. Both of these are powered down right now. They're powered normally by our solar power grid. Right now the circuit breakers are shut off that supply power to these two cabinets. So I'm going to show you how to turn these on. If we come around here, you'll notice inside this cabinet, this would be the West cabinet, we have a label written by our power distribution terminal block there saying DC power from JB1 breaker 5. So JB1 is junction box number 1 in our solar power grid, or you can think of that as being substation number 1. And inside that junction box or substation, breaker number 5 supplies DC power to this cabinet. Here at our East cabinet, we have a very similar label. If you look inside the DC power distribution area, we see DC power from JB2 breaker 5, junction box number 2 or substation number 2, if you want to think of it that way. Looking over here, we see a row of junction boxes. These are all the substations that are part of our solar power grid. So we're going to go over to junction box number 1 right now and open up the door. Inside you'll see a listing of the breaker assignments and what they all do. And true enough, breaker number 5 right there, feeder to West cabinet. Looking inside the junction box, we see 6 circuit breaker boards, 1 on top, 6 on bottom, in the same order as the paper here. So we find breaker number 5. There's 1, 2, 3, 4, 5, second one from the bottom, and we simply press the button next to the red LED to turn it on. You hear a click sound, and we have then closed the breaker. Now to trip the breaker, to turn it off, you press the button next to the green light. That turns the power off to the West cabinet. Now at first the color scheme may seem backwards, but in the electric power industry this is actually the way it's done. Instead of green meaning go and red meaning stop, what we have is green is off or safe, and red is on or energized or dangerous. Even though there's no actual danger here, this is all very low voltage, you can't possibly get shocked here. I'm going to push the button with the red. That will close the breaker, sending power to West cabinet. So come over here to junction box number 2. Same thing here, JB2. Open up the door. We look inside here, and sure enough, breaker number 5, feeder to East cabinet. So we come over here and count the breakers. 1, 2, 3, 4, 5. Second one from the bottom. Press the button next to the red light, and now power's on. So if we walk out here to the hallway, we will be able to see these projects running. So here's our LED-based oscilloscope. Sorry, a lot of glare from the window there. There's our LED-based oscilloscope, the one that's detecting vibrations on the window. And then over here we have our bar graph, the one connected to the sensor here. If you cover it up with your hand, we get response from the bar graph. Again, sorry about the glare from the external window. So that's how you turn the power on to the East and West cabinets. Now, of course, shutting the power off is as simple as going in here and then tripping breakers number 5 on junction boxes 1 and 2. So here we go, tripping breaker number 5 on JB1, and over here, tripping breaker number 5 on JB2. That shuts off power to the West and East cabinets respectively. So, if you happen to leave the circuit breakers on, not a big deal. We have batteries in our solar power grid that store energy, and they can easily run overnight and power both those displays. I try to shut off the breakers at the end of every school day just to conserve energy and to cycle the batteries less, but realistically there's no danger there. So that's how you turn powers on and off to our East and West display cabinets.